All right, this is the last unit 6 notes at 614. You notice 611 through 613 we skipped because that's in BC, so we're not covering that. It's not on the test we're going to take in May. You need to do this worksheet 614. This is the last unit 6 topic, and we're going to have a test, and I think it's going to be the first week of February is what it looks like right now. So we got some more antiderivative rules to do, or these are kind of like, these all look very similar, but the way we do them is all very different, and it just basically takes practice. I'm going to start with B, and the reason I am is I noticed the numerator's variable is one less than the bottom. So anytime I have that, the first thing I want to do is think about U substitution. So I do du, and that's going to give me 2x dx. So if you look, I've got 4x dx up top, and I want only 2. So you got two options. One is we can take the 4 out front and make this a 2, or I can make this 4 into a 2 and just take a 2 out front, and that keeps it equal. So I don't have to create or destroy anything because there's already a 2 and 4, but that 2 stays. So now I can rewrite this as the integral of 1 over u, and then the 2x dx is my du. So this is the natural log of the absolute value plus some c. Well, we can put u in there, or we can type this x squared plus 9 back in there, and that right there is going to be the answer for that one. Okay, so that to me is probably oh, I left the 2 off in front. That 2 should be out here in front because we had to move that 2 into the front of the integral part. So I should have had 2 natural log of x squared plus 9. Okay, I'm going to go over and do this one. Now what I notice is there's no variable in the top. So the first thing I'm going to do is make this a 1 by factoring that coefficient of 4 out in the front. And then I want to think of this 9 as being 3 squared. Now we just did something like this not long ago. If you got an x squared plus a number squared, this in the denominator and 1 with no square root, that's an arctangent problem. So I'm going to write inverse tangent because it means the same thing. So we got that 4 out in front. Oops, I forgot we got to do 1 over a on that one. So the a is that 3. So it's 4 times 1 over 3 times the arctangent. And then it's u, which the u is whatever's over here being squared. So in this case, it's x over the a plus some c. Now you probably want to rewrite this top front part as 4/3. I can get my pen to work. It's not working. What's going on? There we go. 4/3 inverse tangent of x over 3 plus 3. So that would be that answer. And then we got this last one down here. Now this one, what I notice here is these are the same. Now earlier I said the top one would be 1 more if you'd use this method, but this method also works if they're equal because there's not really any function. If you do it, say u equal to the bottom, you take the derivative, you got an extra x up here, and we don't want that. So we're going to do long division again. So I'm going to take 4x squared plus 0x plus 0, and I'm going to divide that by x squared plus 0x plus 9. What times x squared gives me 4x squared? That would be 4. And you get 4x squared plus 0x plus 9. And then remember, this is the tricky part. We have to subtract everything in the bottom. Change the signs. So our remainder here is -9, which has an x power less than 2. So this would be plus -9 all over x squared plus 9. So we would rewrite this integral as the integral of 4 plus -9 over x squared plus 9 dx. So now we're going to break this up and do individual integrals all by themselves. And if you look at this x squared plus 9 with a constant, that should be a flashback to this constant over x squared plus 9. So you're really doing the 4 outside this integral of 1 dx. And over here, we're going to factor out that -9 to the front, and this is going to be the integral of x squared plus 3 squared, just like it was earlier on the other side. And now we can do these normally. So the integral of 1 is x, so this is going to be 4x minus, and then I got this 9, okay? Oh, I made a math mistake. 4 times 9 over here, this should have been 36, my bad. So this should have been negative 36. So that makes this negative 36. That makes this negative 36. I just saw that was not the right thing I was getting right there. So I got this negative 36, and then this is going to be times 1 over a, which is that 3's a, arctan, or you can put inverse tan, of u, which is the x, over a, plus c. Now you probably want to simplify 36 over 3. So this would be 47 minus 12 arctan, or inverse tan, of x over 3, plus c. So some of these are very close, take very different methods, and it kind of makes them hard to do. All right, we're going to come over here and look at this one. Now, the first thing I notice here is I have an x and then a square root. Well, that happens to be one of our problems, and I wish I could get a picture of it up there, but that is going to be the integral that gives you secant out. And I kind of, or arcsecant, sorry, arcsecant. So I'm gonna write that down for you so you can see it. So the integral of 1 over, and the formula is x times the square root of u squared minus a squared, okay, du, and that thing is equal to 1 over a arcsecant, or inverse secant, whichever you want to write. And then you're going to have the absolute value of u, and that's over a plus some c. So that's what I'm doing here. And the conclude of this one for me was you had an x outside and a radical inside. So we need to think of this x as the x is where the u goes, and then 1 squared is the same as 1. So the 1 is the a. So we plug these in, and this is going to be, now you could write 1 over 1 if you wish for the a, 1 going in here. You don't even have to put that in there. And then arcsecant, or I'm going to write secant inverse, and then it's the absolute value of x, because x is where the u goes. And then that's over 1. And again, you don't even have to put the 1 there. You can just put the absolute value of x if you want and put plus c. So the shortest way to write this, if you don't put all that extra stuff in there, would be like that. Okay, this next problem, now it has an x on top and it has an x squared in the bottom. So again, it's kind of like this one. I think that we're going to have to let u be the x squared minus 1, because when I do the derivative of u, I get 2x dx. But I have x dx that I want to get rid of, so I got to create a 2 and destroy a 2. So putting the u's in where they go, I got 1/2 integral of 1 over square root of u du. Now some people get messed up on this and think we're going to go natural log, but this is not natural log, because we would rewrite this square root of u as u to the 1/2. And then we would want to bring that u to the 1/2 up to the top and just use power rule. So we're going to add 1 to negative 1/2, which is going to give me u to the 1/2. And then that's over 1/2, which I've already told you flip that upside down, so that's a 2 out front plus some c. Now these 2's reduce. So I got u to the 1/2, so I'm going to stick x squared back, x squared minus 1 back in for that. And you could write that back in a radical, or you could leave it x squared minus 1 in parentheses to the 1/2 plus c, and that's going to be the answer there. Now this one is even crazy harder. This is more like a Calc 2 or 3 problem, so we do not have the techniques yet. We can't do this yet. So this is later calculus. Okay, and then coming down to these problems down here, again, we got some that are very similar to each other. They all got a natural log in there with them. So the way we do these is going to be a little bit different than the others, and they're all a little bit different from each other. Okay, so we got to figure out what to let u be. This is a u substitution, and if I know that the derivative of natural log is 1 over x. So if you look at this, there's a 1 up here, so this is 1 over x dx, just like this is. So that's why I let u be this. So this is going to be the integral of 1 over u, because the 1 over x dx is the du part. So this ends up being a natural log of u plus some c, but we want to stick this natural log back in there. So that would be the answer on that one. And again, it's practice that gets you where you got to go. Again, this is going to be very similar, except the natural log's on top, but I know 1 over x dx is the derivative of natural log. So I'm going to do the exact same u substitution here. Oops. So there's a 1 up here in front of this, so 1 over x dx is already there, so this is just the integral of u du. So this is u squared, and since the bell rang, I'm not going to write down the u, but it's u squared plus some c. Well, the u is natural log of x. I'm going to stick natural log of x back in there, and that's the answer to that one. And then this one over here is, again, one that we don't have yet. Later calculus is where you would learn this one. This is not on the AB test. Okay, we got 2 more to deal with here, and then we're done with this. I'm going to finish this out even though the bell rang. Hopefully my students coming in will not be loud. Okay, now this kind of problem is a pretty hard problem again. We want to think of this up here as being the integral of, let's see, this dx on the, no, actually I'm going to put a 1 up there. It's going to be 1 over the integral, the square root. I'm going to make this e to the x squared minus 1 squared. So that's e to the x squared minus 1 squared. So back here real quick. So it's kind of similar to this one, and it doesn't look like we're going to be able to do this one. But there is something we can do. We can do on this one that's a little bit trickier, maybe, than some of the things you've seen. And here's what we're going to do. We're going to say, if I let u equal e to the x, du would equal e to the x dx, right? Well, what I can do here is I can solve this for dx and get that dx would equal du over e to the x. Now I'm going to and I should have put a dx up here. So now I'm going to substitute in for this u, and then this stuff right here for dx. So what I can rewrite this as is 1 over, now again, dx is this thing, right? So I'm going to put the du to the side. I could put it up in the top. But there's an e to the x down here, and then I said I was going to let u equal this e to the x. So this is going to be u squared minus 1 squared. Now, do you remember we said u is equal to e to the x? So I can take this u and stick it back in for that e to the x on the next step. And now this is the arcsecant rule again. So if you look here, u from the formula is that u, a is that 1 again. So we got 1 over a again, which is 1 over 1. So I don't need to write 1 over 1, and it's arcsecant, and then it's u over a plus some c, and it should be absolute value. Now a is 1, so I'm going to stick a 1 in here, and then u is the e to the x power, so I'm going to change that to e to the x, and this is what we're looking for on that problem. Again, very tough problem, and you will, like I said, you will not have a bunch of problems like this on the AP test. There might be one of these. Okay, this one is one where you split this up into 2 fractions. So we would rewrite this as the integral of x over the square root of 4 minus x squared. And then this part would be plus a 2 over the square root of 4 minus x squared. And this whole thing would be dx, or we can look at them individually. and put both of them like this. So we would want to do a u substitution over here, I believe. So if we do a u substitution here, we're going to say u is going to equal 4 minus x squared. So du is going to equal negative 2x dx. So I need to create a negative 2, and I need to destroy a negative 2. So that is going to give me negative 1/2 integral of 1 over square root of u. And again, I'm going to do this thing, du. And we're going to be able to find this thing. Plus, over here, this again is going to be one of the old ones that we had. It's our tangent ones. We would want to take this 2 and put it in front and make this a 1. And then we want to think of that 4 as being 2 squared. Now the one that has a, again, this is a, this is u from the formula. This is the arc sign. So we need to take that 2 that we put out front, and it's going to stay out front. And then this is arc sign, and it's arc sign of u, which in this case u is that x. Oops, gotta get that thing out of the way. Oops, I didn't write arc sign down right. So this is arc sign, and then we got u over x plus some c. Now we want to stick the, oops, it's u over a, my bad. So we stick 2 down here, and the u is at x, and that's that part of the formula. And we got to finish this one. So we need to move this up to the top and do our power rule. So it's going to be negative 1/2 u to the positive 1/2, and then divided by 1/2, which means you flip that over and make that 2 over 1 plus, again, plus the rest of this. And then we would simplify this thing. So those reduce. This is going to be a negative, and we stick that 4 minus x back in here, and it's in a radical, so I'm going to stick it back in the radical, plus this arc sign deal. And this is the final answer. So this is the last section from Unit 6, and we will get this done as soon as possible.